Hello class, welcome once again to our session today. We'll continue our discussion on the derivative of logarithmic functions. So we have here logarithmic properties as aids to differentiation. So as you have noticed in our latest example, we made simple the solution of the given function when we are asked to find the derivative of that logarithmic function. Okay, so the next example will also use the properties of logarithms to find the derivative of a given function. Alright, so just to recall about the properties, we have here ln of 1 equal to 0. Second property is ln of the product of a and b. So this is just the sum of the 2ln, ln a plus ln b. And we have here the third property, ln of a to the n, that is equal to n times ln a. And the fourth one is ln of the quotient, a divided by b is equal to ln of a minus ln of b. So the difference, if you have the quotient, ln of the quotient, then this will be equivalent to the ln of the difference of ln of a and ln of a and ln of b. Okay, but take note that the condition here is that a and b are positive numbers and n is rational. So our n is rational. You can use only these conditions, the properties, if they satisfy the condition. So if those conditions are satisfied, then these properties are true, as mentioned in our previous example. So let us solve another example, class, to demonstrate the usefulness of these properties. Okay, so we're given here example number 7. Find the derivative of y. So derivative of y equal to x minus 2 squared y equal to x minus 2 squared divided by the square root of x squared plus 1, where x is not equal to 2. So because when x equal to 2, so what will happen? Y will become 0. So the condition here is that any value for x, but as long as x is not equal to 2. Okay, so for our solution, so first we have to rewrite the given. So we're given y equal to x minus 2 squared divided by square root of x squared plus 1. Condition here is that x not equal to 2. Okay, so to emphasize this topic, class, using the logarithm. So now if we are going to take ln on both sides, so you might ask, why take ln on both sides? So what's the purpose? So the purpose here is to simplify, because you can also find the derivative of this using the other formulas, the quotient rule and differentiation. But as mentioned, it will become so easy if you are going to use the logarithmic functions as well as the properties of the logarithm to find the derivative of the given function. Okay, so taking ln on both sides, taking the natural logarithm. So the natural logarithm is meaning the ln, ln. So taking ln on both sides, so we're taking the natural log or natural logarithm on both sides. So if you take, so we are taking logarithm on both sides, class, it doesn't change anything. if you add on the left side and you add the same thing on the right side, so you're not changing the equation or the given function. Okay, so the purpose, as mentioned, just to simplify our solution. So we have ln. We take ln on both sides, so ln of y equal to ln of x minus 2 squared divided by square root of x squared plus 1. Alright, and take note, the denominator on the right side could be written in a rational exponent. So you can write this as x squared plus 1 raised to the power 1/2. Alright, then applying the properties, or differentiating, or before we differentiate, let us apply the properties first. So ln y equal to, so this is in the form of property number 4, right? So this is ln a over b. So applying this equivalent of this ratio, so which is the difference, so we can write this as ln of a, or a here is x minus 2 squared, then minus ln of x squared plus 1 raised to the power 1/2. Okay, and then applying the other property for the first term, so ln y equal to, so the first term here follows this one, property number 3, right? So property number 3, so you can write this as, because it is in the form of ln a to the n, so this is equivalent to n times ln a. So rewriting it in this manner, so we have 2 times ln of x minus 2. Alright, then minus the second term also takes the form of property number 3. It's also in the form of ln a to the n, so we can rewrite it to its equivalent, n ln a. So n here is 1/2 times ln of x squared plus 1. Okay, so now taking the derivative on both sides, or differentiating both sides, okay, so we will apply the formula. If you can still remember, a while ago in our latest example, we have the formula that derivative of, or if you have f of x equal to ln x, so f prime, so then f prime of x is simply 1 over x. Okay, so this is one of the formulas that we can use. And the other one is if you have derivative, no? If you take the derivative of derivative of ln u with respect to x, so this is equivalent to u prime over u. So take note, class, that this one, no, I forgot to emphasize this in our last example. So actually this is just the same as, remember, in our other example also, example number, I think number 5. So derivative of ln u with respect to x. So remember, we have this 1 over u, then times the derivative of u with respect to x. So actually, class, they are just the same. So it means that derivative of u with respect to x, that is just equivalent to u prime, right? So that is just equivalent to u prime. So if this is equivalent to u prime, the derivative of u with respect to x, this is just equivalent to u prime. Alright? So that's why whether you derivative of, this is so derivative of ln u with respect to x, so this is d over dx. Okay, so they're just the same. So that's why you can use either this one or this one. Okay, so we'll use that formula to solve this. So for ln y, so this is our u, so this would be when you take the derivative of ln y, so this is just the same as y prime. This is just the same as y prime over y equals, so this is constant, so 2 constant, ln, so derivative of ln u, so for this part here, so what is our u? Our u is x minus 2, right? X minus 2, and the u prime here is derivative of x minus 2, derivative of x is 1. Okay, so using the formula, so this is equivalent to 2 times our, because this is u prime, no? U prime over u, or that is derivative of u, which is 1 over u, where u is x minus 2. So this is the same as, ang u prime natin is 1, so divided by x minus 2. Alright, then minus 1/2. So now for this part, so what is our u? So our u here is x squared plus 1, and our u prime, so just the derivative of this, so derivative of this is simply 2x. So using the formula, derivative of ln u is u prime over u, so u prime over u. So what is our u prime? Our u prime is 2x, so we have 2x divided by u. Our u is x squared plus 1. Alright, and then we have 2 here, 2 at the numerator, 2 at the denominator, so that becomes y prime over y equal to, so 2 divided by x minus 2 then minus, it would be x over x squared plus 1. Okay, right, so I will continue here. I'll continue it here. So y prime over y equal to, find the LCD. No, what's the LCD of this? So on the right side, you just find the LCD. So the LCD here is just the product, no? Product of x minus 2 and x squared plus 1. So x minus 2 times x squared plus 1. Okay, so the rule here is you divide the LCD, the least common denominator, by the denominator of its term. So this LCD divided by this, so what is left is only x squared plus 1, then multiplied it by 2. Okay, so that would be 2 times x squared plus 1, then minus, so this is minus here, so this is also minus. So this LCD divided by this one, so what is left, then multiplied by x. So we have x times, so this one divided by this, so what is left is only x minus 2, so times x minus 2. Alright, and after that, so y prime over y equal to, so try to simplify the numerator. So just copy the same denominator, x minus 2, then x squared plus 1, then you just distribute 2. So distribute 2 and multiply, and also this one distribute minus x and multiply. So the numerator becomes, so we have 2x squared plus 2, then minus x squared, then plus 2x. Okay, so y prime over y equal to, so we have 2x squared, so we can combine similar terms. We have 2x squared here, 2x squared, we'll combine it with minus x squared, so we have 2x squared minus x squared is simply x squared, then you have plus 2x, rearranging, so you have 2x then plus 2, then write down the same denominator, x minus 2 times x squared plus 1. Okay, and then since we are asked to find the derivative of y, it means we are asked to solve for y prime, right? So to solve for y prime, so we need to multiply both sides by y, or simply cross multiply y, so that you have y prime equal to, so y times this whole thing here on the right side, x squared plus 2x plus 2, and divided by x minus 2 times x squared plus 1. Okay, then after that, just substitute y, the value of y. Okay, so uh, we know that y is equal to our given. So our given is x minus 2 squared divided by the square root of x squared plus 1. So if we call this as our equation 1, and if we call this as our equation 2, so you just substitute, no? Substitute. Just substitute equation 2 and equation 1. So take note, our y is the given function. Alright, so substituting, so we have y prime equal to so instead of y, so our y given as x minus 2 squared divided by square root of x squared plus 1, then multiplied, so you multiply this by x squared plus 2x plus 2 divided by x minus 2 times x squared plus 1. Okay, and so if you look at the numerator and denominator, so we have a common factor here. So there is this, at the denominator we have x minus 2, at the numerator we have x minus 2 squared. So we can take out one of the factor there. So y prime is equal to, so what is left at the numerator, we have x minus 2. Alright, so the rule in multiplication of fraction, just multiply the numerators and multiply the denominators. So we have x minus 2 that is left, no, after the division of x minus 2, and multiplied by the numerator x squared plus 2x plus 2. Alright, and divided by, so this x squared plus 1, that can be written as x squared plus 1, the square root of it. So you can rewrite this as x squared plus 1 raised to power 1/2, then multiply this with x squared plus 1. Okay, so that we can combine these two. So y prime is equal to, so x minus 2, I have x squared plus 2x plus 2 so here we have the same base. This is understood to be power 1, right? So this is understood to have a power 1. So you have x squared plus 1, you have also x squared plus 1. The power or the exponent here is 1/2. The exponent here is 1. So the law of exponent, if you have the same base, you just add the exponents. So it means that we can write this as x squared plus 1 raised to a power. What is 1/2 plus 1? 1/2 plus 1 is just equivalent to 3/2. So 3/2. So therefore, our final answer is, so this is our final answer, y prime equal to x quantity x minus 2 times quantity x squared plus 2x plus 2 divided by x squared plus 1 raised to power 3/2. Okay, or you can also rewrite this as y prime equal to x minus 2 times x squared plus 2x plus 2, then multiplied by x squared plus 1, then cube, and then square root. Alright, so that's it. So either of this answer, class, is already correct. So let's review. So we have x squared, quantity, or y prime is quantity x minus 2 multiplied by quantity x squared plus 2x plus 2 and divided by x squared plus 1, quantity x squared plus 1 raised to power 3 halves, or you can express this as in radical form. So this is the power, x squared plus 2, then power 3, then this is the index of the radical, which is 2. Alright, so class, so I hope you still able to follow the procedure in solving this problem. You can check the answer, class, using the other formula, no? The derivative of the given function y equal to quantity x minus 2 squared divided by the square root of x squared plus 1, no, using the quotient rule. So you will arrive at the same answer. Okay, so thank you very much, and hope to see you again in our next example. I will make a little review, class, before we go to the hyperbolic functions, derivative of hyperbolic functions and inverse hyperbolic functions. I'll add a little more examples on the derivative of exponential functions. Okay, so thank you very much. Have a nice day. Stay safe and healthy always. God bless. Bye.